we know that sound plays an integral role in order to communicate with each other. Imagine you are telling someone about your pain and no one listens to it. It feels so bad. And that's the same thing what happens on the astronaut on the moon when they first landed. They had to be very precise so that they could calculate each and every amount of thing in order to communicate on the moon. As we know, there is no atmosphere and internally there is no communication possible using the sound that we can hear on Earth. In fact, if there was no air in this room, in fact I wouldn't be alive then, but if there is no air in this room, you cannot hear me, because the thing that gets my words from my mouth into this mic is responsible for the production and the propagation of sound. So in this video, we are going to find out that what are the different characteristics and functions of sound that are very important in order to just live in our life. So let's start. Sound is defined as the energy which is traveled through a medium, or it is just a form of energy. Well, we can say that sound is a form of energy which uses air or any type of medium to travel, making it a longitudinal wave, which means an electromagnetic wave which travels in a up-down motion, what we call the tuff and crest. Longitudinal waves travels in different arrays of contraction and the rarefaction. You have been seeing these kind of diagrams in which some places are more denser filled with airs and some are not, where the air is absent in a abundant quantity. These are the basic things which help in amount of to propagate that thing. There are multiple kinds of experiment in order to prove this. If you take a slinky and just make it so long, you can just move your hand up and down, and you will notice that the particles will remain at the same place, but they just oscillate up and down in order to move that energy from one point to another. Which means there is not an actual thing or the actual transfer of the particles, but there is only the transfer of energy which happens. But if you take the same slinky and instead of moving it up and down, you just hold a piece of it and just move towards you, and when you just get rid of it, it will form some kind of motion or the jiggling motion of atoms or any type of particles in order to again propagate that energy to the another source. Where here we are not actually saying any kind of the transverse movement of particles or the rapid movement that we had using our light energy. You will find some kind of particle movement which is just seen in the sound energy, where the particles are moving within the direction of the motion. You might be seeing different kinds of speakers around you and they have different kind of ratings on it. So now let's talk about the characteristics of sound. Sound can be defined as many things. As you might know, there are frequencies, amplitude, time period, and many things which we are going to cover. So let's start with the frequency. Is, as you might already know, is the thing which is assigned to the source of that object, which means no matter where you go on the moon, Mars, or anywhere, the object which is producing sound always have its own frequency. The frequency doesn't change or it doesn't depend on the medium itself, because it is the property of the object or the source. Frequency is defined as the number of oscillations in 1 second, which means if I have the total number of oscillations and upon I have 1, so that I will get the accurate reading in frequencies. The SI unit for the frequency itself is hertz, or denoted by a capital H and a small z, which is also capital but just decapitalized, so it is looking a bit cooler, as you might already know. Then we talk about the amplitude. Well, amplitude depends on medium, but it also a kind of the property of the source itself. It is same like frequency, but here it is not a time or a number. It is length from the mean position to the extreme position. And again we take an example of a pendulum. So if I swing a pendulum, the starting point or the mean position in which there is no displaced pendulum, and when I move it to the extreme ends and just leave it, the furthermost the pendulum goes, and the distance between the extreme and the mean position is the amplitude of that pendulum. If you draw some kind of transverse wave, or well, We cannot actually show, or well, we cannot actually make a diagram of a longitudinal wave. So just to understand, we make a compression graph of the actual sound frequencies and sound, so that we could study about the crests and troughs that comes in between these types of waves. Okay, so amplitude is just seen as the line which is your baseline, which is also counted as 0. Below it is negative and above it is positive, as we all know that abscissa is always positive above the above the y-axis. So according to which the distance between the crest or the uppermost part and the mean position will be equal to your, well, what you call it, the amplitude. Now let's talk about the time period. Time period is just like frequencies, but there is a bit of matter of confusion here. See, frequency is number of oscillations in 1 second, and the time period is the number of, or is the amount of time what each wave is taking. For example, if I have the number of waves in 1 second, that is a different thing from the number of, or the time that it takes to complete one oscillations. So you can say that f is 1 upon t, or the time that it takes to complete the one oscillations. After all, it will cancel out and give you denominator 1, which is always a whole number value. Now let's talk about the mediums. Well, sound is an energy and it requires on the thing what we call the medium, right? The particles, in order to produce that sound from the starting to end. That's why we have different kinds of mediums around us. We have, well, liquid, we have gases around us, and we also have the solids, right? There are also two different kinds of matter, or the state of matter, which are also the Bose-Einstein condensate and the plasma, you know, right? So, according to the basic science, we note that the sound or the speed of sound is fastest in the medium of solid. Which means if I take a long iron bar and I tinker at this point, I will hear the sound fastest in that medium. Compared to liquid, it is lesser than solid and more than gas, and in the gas it is the lowest. Well, it also depends on the density. Well, the same thing that we discussed, right? Solid are more denser than the actual gases that you have. The next thing comes is the kinetic energy in particles. You might be knowing that temperature also affects the sound speed. Well, sound travels faster on warmer days. What does that mean? It means that the motion that these energies were giving in order to move the particles, but in warmer days when the kinetic energy of the gases is more, the particles are already vibrating, so that you have to use very little or the fraction of your energy that you are carrying to get from one source to the other. Which means that more kinetic energy results in more speed of sound. You might be knowing this fact that in warmer days we have those kind of broadbands like stuff where you can communicate from one point to the other. The thing is, as these sound energy is a mechanical wave, it depends on the medium, or it cannot be traveled through that medium. Well, it has been proved using the bell jar experiment, in which you ring a bell in a vacuum and it doesn't make a sound at all. It doesn't even vibrate. Actually, you have to touch the cylinder or the container in order to feel that sound that the ring is making. Well, there are different things. Well, there are the echoes and the reverberation, which is used in different kinds of movies to make or enhance and enchant the sound that you are speaking, right? And that's the actual secret of the bathroom singing that you have, because in a small hall, if you speak something, the value or the thing or the words that you are speaking are actually, well, repeated again and again, because the words that you have actually reflect those words and again into your source, which is your ear, so that it can be sound again and it sounds a bit better. It sounds like a singer. Well, there are again different things and characteristics of sounds, like for example, to produce the sound, or in gaseous medium, the speed of sound starts from 320 meters per second to 344 meters per second, and notice how that number always increases in from gases to solid. Like it also reaches 1034 in steel or any type of solid that you have. Well, that's the case. If you have a very long railing along a skating park, if you put your finger at this point and you put your friend at that end in order to listen and feel those vibrations, he will actually vibrate, he will actually feel those vibrations, so that you have produced those, and these vibrations are carried through the particles of that sound. So that's all for today. Thank you.